What is climate change? By My Zero Carbon. The best time to act is now. Please remember to like and share this video and subscribe to my channel. In this video, I will talk about what is climate change, what is causing it, where is it happening, and why does it matter? So what is climate change? In a nutshell, climate change is a large-scale, long-term shift in average temperatures and the pattern of the planet's weather. So let's look at this in a bit more detail. What is climate? The first point is that climate is not the same as weather. In the weather forecast, we hear about weather. Sunny intervals, rain, snow, clouds, storms, frost, and heat. The weather happens in one place at a certain time. Climate is what happens in the long term over a large area. This includes the seasons: spring, summer, autumn, and winter, the monsoon season in India, April showers, and the concept of a white Christmas. Climate shapes our identity, our culture, and how we grow food. What is causing climate change, and where is it happening? To answer this, we need to look at our whole planet. Planet Earth is surrounded by a very large layer of gas we call the atmosphere. The atmosphere stretches 10,000 kilometers into space. Here you can see it to scale relative to the size of planet Earth. As you go away from the Earth's surface, the atmosphere gets thinner and thinner until you reach space, a cold, dark vacuum. The atmosphere is essential for our survival. It protects us from UV radiation that would cause skin cancer. It contains the air we breathe and the gases plants need to thrive. Without it, we would freeze to death at night and roast during the day. Our neighboring planets have much thinner atmospheres. Venus is closer to the Sun and 460 degrees Celsius hot. Our nearest neighbor, Mars, is further away from the Sun and on average minus 60 degrees Celsius cold. Earth is on average a pleasant 15 degrees Celsius warm, thanks to our atmosphere. I said earlier the atmosphere stretches 10,000 kilometers out into space, but 95% of all gases are in the layer closest to the planet's surface, up to 50 kilometers out. Can you see the red line? The thickness of the line is not to scale. The lower atmosphere is actually much thinner. Take an apple. An apple skin is about 3 millimeters thick. In proportion, the lower atmosphere, where our weather and the climate change processes take place, is 40 times thinner than the skin of an apple. So next time you eat an apple, think about how fragile and sensitive the atmosphere around our planet Earth is. Let's take a closer look at the lower layers of the atmosphere. The stratosphere stretches up to 50 kilometers out. It contains over 3/4 or 78% nitrogen gas. 1 in 5 or 21% of all gas molecules are oxygen and 1% a rare element called argon gas. The troposphere stretches 10 kilometers out. Tropos actually means change because this layer is in constant change. This is where our weather is happening. It has a very similar concentration of those gases, but the density of the gases is a lot higher. These three gases make more than 99.9% of the gases in the atmosphere and do not affect climate change. In addition, the atmosphere has tiny amounts of other gases. This includes carbon dioxide, methane, nitrous oxide, and water vapor, and lots of other entirely man-made gases. These gases are also known combined as greenhouse gases. Greenhouse gases trap heat on planet Earth and are the reason that on average Earth is a pleasant 15 degrees Celsius. Without carbon dioxide, Earth's surface temperature would be an average of a freezing minus 80 degrees Celsius. Sunlight is radiation energy. When it hits the planet's surface, some of it is converted to heat, some of it bounces back as warm infrared radiation. But on their way back to space, the greenhouse gases force some of this radiation back to Earth and trap the energy and the heat within the lower atmosphere. So the greenhouse gases act in the same way as the glass panels in a greenhouse do. They make everything inside warmer. Just in the period from 1998 to 2005, greenhouse gases have increased this effect with an additional sun power input into planet Earth by 28 million megawatts. That is about 23,000 times the power output of the UK's largest nuclear power station. The greenhouse gas effect is essential for our survival. It has been very finely balanced for thousands of years, but human activity has brought it out of balance. For millennia, carbon dioxide levels have gone up and down around an average of about 230 parts per million, but never above this line. And then from 1850 onwards, it has shot up, reaching 315 parts per million in 1958 and 417 parts per million in 2021. Things started changing in 1850 when the Industrial Revolution took off in the United Kingdom and soon after in other so-called developed countries. Since then, human activity has resulted in the emissions of 1.7 trillion tons of carbon dioxide. That is a 1.7 with 11 zeros. Carbon dioxide concentration in the atmosphere reached 417 parts per million in the summer of 2021. This box represents 100% of all carbon dioxide emissions caused by humans. These 10 countries between them are responsible for over 2/3 of all carbon dioxide emissions since 1850. These are also among some of the wealthiest countries on the planet. The rest of the world is responsible for only 32% of all carbon dioxide emissions. The main factors for the increase in carbon dioxide emissions have been the burning of fossil fuels like coal, gas, and oil, and large-scale removal of trees and woodlands. Pretty much everything you and I do and everything you and I consume contributes to carbon dioxide emission. The largest contributors are typically going on a flight, driving your car, heating your home, and consuming food, especially meat and dairy products. The carbon dioxide emissions caused by one individual are called a person's carbon footprint. In the UK, this is on average 7 tons carbon dioxide per person per year. That is the same weight as 2 elephants. Compare that to the annual carbon footprint of a single person in the UK. The annual weight of household weight is actually pretty small, a mere 390 kilograms. But because carbon dioxide is a gas we cannot see nor smell, the problem may sometimes seem not to exist. While in comparison, the very visible household waste seems to be a much bigger problem than it is. As mentioned before, methane is another greenhouse gas. Man-made emissions result from production and burning of coal, gas, and oil. Livestock, waste, rice cultivation, and biomass burning. Nitrous oxide emissions come from waste, agricultural soil management, and fuel combustion. Some greenhouse gases are a lot stronger in forcing radiation back to Earth than carbon dioxide. Some live just a few decades in the lower layers of the atmosphere, like methane, others for about 100 years, like nitrous oxide. Individual carbon dioxide molecules cycle between the atmosphere and the oceans frequently, but a carbon dioxide emission today will affect atmospheric concentrations for 200 to 2,000 years, while some man-made chemical gases stay in the atmosphere virtually forever. The effect of carbon dioxide and other greenhouse gases is that more solar energy than ever before is hitting the planet's surface and staying within the lower levels of the atmosphere. This is contributing to global warming. You can see here that most years since 1900 have been warmer than the average temperature between 1850 and 1900, with the warmest years appearing in the last decade. We have now reached about 1.1 to 1.2 degrees Celsius warming compared to pre-industrial times. This warming stripe is also a great way to show that there has been a clear trend of years getting warmer in the last 170 years. Each stripe from left to right represents the temperature of 1 year from 1850 to 2020. The dark blue are the coldest years and the dark red the hottest years. Why does it matter? All this extra energy is causing the climate to change. It is not just getting warmer, also weather patterns are changing. Climate change is already happening now. Changes in the climate we can already observe are more and more extreme heat waves, droughts, flooding, and storms. The Intergovernmental Panel on Climate Change published a key report in August 2021. This report says that climate change is widespread, rapid, and intensifying. The report, developed by hundreds of scientists and based on government research and data, also says there is no doubt that climate change is definitely caused by human activities. It continues to say that global warming of 1.5 degrees Celsius and 2 degrees Celsius will be exceeded during the 21st century unless deep reductions in carbon dioxide and other greenhouse gas emissions occur in the coming decades. Mathematical models for climate change say that avoiding a temperature increase by 1.5 degrees Celsius is critical. Go any warmer and climate change will get out of control and lead to a vicious circle of ever faster warming. Vicious circle downward spiral events include thawing of the tundra permafrost, releasing methane and carbon dioxide, reduced ice in the Arctic and Antarctic, reflecting less solar energy back into space, leading to ocean water warming and more ice melting, and oceans releasing rather than storing carbon dioxide. The consequences of exceeding 2 degrees Celsius temperature increase would be catastrophic for the economy, creation, and in humanitarian and human health terms. Acting on climate change is now very urgent. We still have time left to act. You can find out more about what you can do on this YouTube channel and its playlist, on my blog, and by following My Zero Carbon on Facebook or Twitter. If you would like to see more videos like this, please support My Zero Carbon on Patreon or LiberaPay for a regular donation, or Ko-fi for a one-off donation. You can find out more information and links in the description below. Please remember to like and share this video and to subscribe to my channel. My Zero Carbon. The best time to act is now.